Hi guys! So here is our video as our introduction to logarithms. So we're just going to spend some time today talking about what a logarithm is and working with logarithms. So what is a logarithm? Maybe you've heard this word before. So a logarithm, most importantly, a logarithm is an exponent. It's really just another way about thinking of exponents. So the other big takeaway here is that logs help us find exponents because logs are equal to exponents. And let me show you what I mean by that. So we can use logarithms to rewrite exponents. So for example, you can see here I have some exponents. 2 to the 4th is equal to 16, which we know is true. If you notice, I keep saying that logarithms are equal to exponents because here I have a logarithm and it's equal to the exponent from over here. So logarithms are just a fancy way of rewriting exponents. So what I want to do is I just want to sort of really break this down here. So looking here, we can rewrite anything that's in an exponential form to look like a logarithm. So the biggest pieces are that the logarithm is equal to the exponent. So my 4 here from my 4 exponent. The base of the logarithm, so we would read this right here as log base 2 of 16 is equal to 4. So log base 2 of 16 is equal to 4. So that's how we would read this. So the base of my exponent is the same as the base of my logarithm. What the exponent is what the logarithm is equal to. And what the exponent is equal to is this sort of chunk of this logarithm over here. So sometimes you'll see some sort of tricks to going back and forth here is that 2 to the 4th power is equal to 16. So 2 to the 4th is equal to 16. That's what this logarithm means. So let's keep going and try some others. So we can use logs to rewrite exponents. So for example, 2 to the 3rd power is equal to 8. 3 to the 4th power is equal to 81, and 5 to the 2nd power is equal to 25. So notice here, all of these exponents is what the logarithm is equal to. So before, if we had something that was like 2 to the x power is equal to 7, we aren't able to solve this, right? This isn't something that's squared. We can't take the square root of both sides. We can't divide both sides by 2. How do we get this little exponent down? We would put it into a log form. So I can write the word log. The base of the exponent is 2, so the base of my logarithm will be 2. So log base 2 of 7 is equal to my exponent, which is x. And as we get through some of these, I'll show you how to solve some of these logarithms here. But the biggest takeaway for this video is just to know that a logarithm is another kind of function, and it's the inverse of an exponential function, or it's another way of thinking about an exponent. So generally speaking, a logarithmic function to the base a, where a is bigger than 0 and it's not equal to 1, is denoted by y equals log base a, so read as y is the logarithm to the base of a, and is defined by this. So the log with the base of a of x exists when x is equal to a to the y power. And when we think about exponential functions, we just finished that unit. So I knew that when I graph something like 2 to the x, that my graph would look something sort of like this, and it wouldn't exist below the y-axis. So really similarly, thinking about how logarithms are sort of like the inverse of exponential functions, instead of my function here only existing above the y-axis, the opposite of that, my logarithms only exist for x values that are bigger than 0. So thinking about how these functions, reflect over the line y is equal to x, these guys will look something like this. So that is just sort of, generally speaking, a logarithm is an exponent. And we'll really dig a lot deeper into this here, this definition. But for now, we just want to sort of work with some of these logarithms. So the base of the log is the base of the exponent. The logarithm is equal to the exponent. And whatever we're taking the log of is what my exponent was typically equal to. So here I'm going to, let's make this a little bit thicker. I'm going to write the word log. The base is going to be 2 because that's the base of my exponent here. So log base 2 of 32 is equal to 5. And I can check because I can say 2 to the 5th power is equal to 32. So let's keep going down here. Log with a base of 5 of 125 is equal to the exponent, which is 3. And lastly, log with a base of 7 of 49 is equal to 2. Or I can come back here, 7 to the 2nd power is equal to 49. So just going back and forth between these logarithms and these exponentials. So here I have some logs. Let's rewrite them as exponents. So 2 to the 6th power is equal to 64. 4 squared is equal to 16. 4 to the x power is equal to 64. So again, just going back and forth between these two forms. So this says calculate the following logarithms. So sort of a general rule of thumb that I always remember as I'm solving these is that if I ever have a logarithm and I'm stuck, I always put it into an exponential. And if I ever have an exponential and I'm stuck, then I put it into a logarithm. So in this case, this could be, I don't need the highlighter. This could be equal to y or x or m or any variable. Putting this into an exponential tells me that 4 to the x power is equal to 64. So 4 to the what power is equal to 64? 4 to the 4th power is equal to 64. So in this case, x is equal to 4. This one right here, 4 to the something is equal to 16. I know that 4 squared is equal to 16. So here, x is equal to 2. This will be equal to 3 because 5 cubed is equal to 125. Down here, 343 to the something power is equal to 7. 343 to the something power is equal to 7. We're going to come back to really figure out how to solve these sorts of problems in just a bit. But for now, we'll just go back and forth between working with logs and working with exponents. So convert between exponential and logarithmic form. So here, I'll write the word log. The base of my exponent is 1/5. I'm taking the logarithm of y, and this will be equal to my exponent. So here, log base 9 of x is equal to y. Log base 6 of x is equal to y. Log base b of 123 is equal to a. Log base u of v is equal to -14. 8, that's not what I meant to do. Here, log base 8 of a is equal to b. And over here, we'll just do a couple. And I always sort of like to do this little swoopy, these little arrows here. So u to the v power is 15/16. 7/4 to the y power is equal to x. u to the negative 16 is equal to v. Here, v to the fourth power is equal to u, okay? And so that's it. So that is sort of the beginning of this logarithms unit, just sort of what is a logarithm, working with logarithms, and working with exponentials. So you have a problem set that you can work on, and I suggest that you take some notes here, maybe print this out and do some of these problems with me along with the video before you really tackle that problem set, because it can get a little tricky and a little bit confusing if you don't sort of have the right mindset for it.